Alright, so we're getting ready for the torque lab. Okay, so what we're going to do is we're going to take a meter stick and we're going to take a strip of paper. We're going to create like a little basket for the meter stick. So fold it in half, fold it in half again. Okay, and then you can cut like a little window out of it to figure out so that you can actually read like what the ruler says underneath it. Okay, so something like this. Okay, and it's like a little basket so you can hang the ruler on it and get it to balance. Okay, you're going to want to like poke a hole in it, and then you'll tie some string through it, and to make the hole big enough to tie a string. You fix that real quick. Okay, so I punched a hole, tied some string through it, and now you can adjust this until you get it to balance. Okay, and the string will be right over wherever the center of mass of that meter stick is. So probably somewhere around like 50 right here. Okay, and now once you get it to balance, so we're really close, you want to tape it there so that it doesn't slide. Okay, so we'll tape it right here, and then what I'm going to be doing is I'll be taking other masses, and at first I'm going to hang masses on here and get them to balance. So you take a mass, make a little loop with it, and we can hang it on here. Okay, and so at first I'm going to say, okay, with that mass there, I'll get another mass and hang it on the other side and try to get it all to balance. Okay, and I'll do that, and then I'll write out a net torque equation to show that the total torque here combined is close to zero. It should be, I mean, ideally it's going to be exactly zero, but of course it won't be, but it should be close relative to the quantities of torque that we're generating from these masses. Okay, later you'll put a mass on here and then calculate actually where to place another one. Okay, and then once we've done that kind of stuff, we're actually going to untape the center of mass here, remembering what the location of that center of mass is, and we're going to move it to some other position. We'll say like 25 centimeters about. Okay, and we're going to hang mass on the end so we can try to get it to balance. So if I put it maybe like this, yes, I have to move it closer to get to balance. Okay, so maybe still not quite there. Probably want to use a slightly smaller mass than what I'm using. But here you can see, still not balancing. We're close though. You see we're just starting to get to balance. Okay, and now based on the location where this is when it's balancing and this distance, and my knowledge of the fact that the center of mass is at a certain point right here that I determined earlier on, I can actually use this to calculate the mass of the meter stick, okay, using torque. Okay, so that's, you're going to go ahead and calculate the mass, and then you'll make additional predictions on, for when the meter stick is off balance, where you might hang a mass to balance out the meter stick. Okay, and so this is what we're going to be working on for our torque lab. You're going to get a day, and so I wanted to give you an idea of what we're doing so that you'd be prepared. So I'm going to give you like a sample calculation, what it might look like, and then we'll wrap up the video. Okay, so as we're working, some of the stuff, once you get started with the lab, so you have your meter stick, you'll have your fulcrum somewhere around the 50 centimeter mark, maybe not quite exactly, but somewhere around there, and you'll get it to balance with masses like this, okay, at different locations. And we just want to set up a net torque equation to show that this is approximately zero. So we'll say that this direction is positive because it's counterclockwise, and so from this torque we have, from this object, it's pulling down with some weight at some distance r, and then this other one's pulling down with additional weight at some distance r, the opposite direction. We'll call this R1 and R2 and that M1 and M2. And so this should be, it won't be exactly zero, but we want it to be approximately zero. Okay, and then later we can say, okay, here's my meter stick. I'm going to put a 100-gram mass some distance away, maybe like 10 centimeters, and I want to figure out where to hang a 200 gram mass so that I can balance it out. So then I would use the same equation, and I can do net torque to find basically what this R would be. Now, if this is 10 centimeters, let's say this is the 50 centimeter mark, that would make this at like the 40 centimeter mark. That would make R equal to 40 or to 10. It would be equal to 10 because that's the distance away that it is. So we're not looking at position, we're looking at distance away from the fulcrum.